All right, we're on day 2 of simplifying radical expressions. So you should have already filled out this top part. The answer to the first one would be no, and the answer to the second would be yes. You can pause the video to see if you need to. And the same way we were speaking about like terms, you also can not add or subtract them if they're not like terms, but you can multiply them and divide them. So we've done this before, but this process is outsides with outsides. So 3 times 5 give you that 15 on the outside. And then 2 times 10 would give you that 20 on the inside here. And then from there, you're just going to simplify normally. So what we're going to do here is we're going to do outsides with outsides. So 2 times 3 would be 6. Insides with insides would be 5 times 10. One way that you can write it is you can do 5 times 10 like this, and then break down that 10 into 5 and 2. So really what you're saying here, instead of 10, is times 5 times 2. That way you can see, okay, these are a pair. That means that they can go to the outside. So 6 times 5, square root 2. That 2 doesn't have a pair. It's going to be left over. So we would have 30 square root 2. Right, so you can see those along the way there. So then, for example, this would be 2 on the outside and 18 on the inside. 18 is 9 and 2. The square root of 9 would make a 3 on the outside here. So 2 times 3 on the outside with a 2 left over. So we have 6 square root 2. And then on this one here, we would have negative 2 times 5, negative 10 on the outside. I'm going to leave the 6 here. And the 15, I know I can break into 3, 5. While I'm at it, I might as well break up the 6 into 2 and 3. So I can see that the 3's have a pair going to the outside. Negative 30, square root 2 and 5 are left inside, so 10. That would be my final answer there. So that is how I would multiply them and then simplify. So for the following ones, we're going to use distributive property. So I'm going to go ahead and distribute this in here and that in there. So I would do 3 times 4 would be 12, square root, put 3 here, 3 times 8, so kind of like holding that spot. And then 3 times negative 5 would give us 15. And then square root 3 times square root 2 would be square root 6. I can leave it as 3 times 2 here. From here, I'm going to see if there's anything I can break down. I can break down the 8 into 4 and 2. Square root of 4 would give me 2 on the outside, so 12 times 2 on the outside. It's going to leave me with 3 and 2 left over inside, which is 6. So I would have that minus 15. And 3 and 2, there's nothing, so square root 6. So I can see here I would have 24 square root 6 minus 15 square root 6 would give me 9 square root 6, because I can combine those together. Kind of like 24x minus 15x. That would be my first one here. The second one, I can see there's 2 terms times 2 terms, a binomial times a binomial. So I'm actually going to use the box. I think that that's an easier way to think about it. So I'm going to have square root 7 times 2 square root 7, and 2 square root 7 minus square root 3. So in the first box, I would have whole number 2, and then square root 7 times square root 7 would be just 7. It'd be square root of 49, which I know is 7. I would have a negative here. Negative 7 times negative 3 is negative 21. I'd have 2 times 2 would be 4, square root 21, 7 times 3. And then negative 2, so it would be this negative times the 2. And then square root of 3 times square root of 3 is just 3. So I'd have 3 left over there. So when I write these out, I would have 2 times 7, 14. I would have positive 4 square root 21, take this one out, minus square root 21, minus 6. That's that last part there. So in this case, I have like terms here. I see 4 square root 21 and 1 square root 21, or negative 1. So that would make 3 square root of 21. And then I have 14 and negative 6, which would be 8. So put that 8 in front there. You can double check 3 and 7. Those don't have anything in common, or that can be taken out. So I would just have square root of 21. That would be my answer for this one. Go ahead and try these two examples on your own and double check with your partners. Go ahead and pause the video for a second. Cool. So this next section says, what is the difference between the expressions square root of 12 and square root of 16 in terms of decimals? So square root 12, when you find the decimal is going to go on forever and ever. And square root 16 is just the number 4. So because of the difference, this is like 3 point something, something, something. Because of the difference, square root of 12 is what's called an irrational number. And square root of 16 is a rational number. To rationalize something means to make that thing rational. So to make it kind of like an easy number, the technical definition is to make it able to be a fraction. So consider the expression this 3 over square root of 2, in which the numerator is a rational number, but the denominator is an irrational number. Suppose we wanted to rationalize the denominator. That is, make the denominator of the expression a rational number. So we want to make the denominator rational. We do not want to have the square root on the bottom. So what we're going to do is we're going to take 3 over square root 2. We're going to multiply the numerator and the denominator by square root 2. So times square root 2 would give me 3 square root 2 on top. And then square root 2 times square root 2 would just be 2. So I can see that that does indeed rationalize the bottom and gives me just a whole number there. So this would be the more appropriate answer. Go ahead and fill in this next section. It says, now using your calculator, find the decimal equivalent of the first fraction we were using and the expression that we just found here. So you're going to find 2 decimals, and they should be exactly the same. Otherwise, we did something wrong. And you're going to answer this question in your words. Why does this process not change the value of the expression? So you're going to write something here. Okay. You're going to go ahead and rationalize each of these denominators. I'll get you started on the first one. You're going to multiply by square root 3 on top and on bottom. Go ahead and complete that. And then we're going to remember our use of I. So we're multiplying this number and this number. Go ahead and pause if you're still here. Fill these problems. Go ahead and do these problems. Okay, assuming you're back, we're going to multiply these 2 units together. So 3 plus 2i times 3 minus 2i. You get 9, negative 6i, positive 6i, negative 4i squared. Remember, the good part about that was that the i's canceled, and you had 9 minus 4i squared. I squared turns into negative 1 times negative 4, which would give you positive 4, and 9 will give you 13. So we can get rid of all the i's there. So remember that when 2 complex conjugates are multiplied, the result is always a real number. So we're going to do this same type of thing when we multiply irrational conjugates. So we're going to multiply things that have square roots in them to see if we can get rid of the square root. So here we have 5, square root of 5 plus 2, square root of 5 minus 2. We get square root of 5 times square root of 5 is 5. This would be negative 2 square root of 5, positive 2 square root of 5, and negative 4. That means these will cancel and leave you just 5 minus 4, which is 1. So pretty cool that we can start with 2 things that have rationals in them and come out with just an individual number. That's the goal. Go ahead and see if that will work for each of these problems here. Try this one, and that one there. Remember, you're using the box. Go ahead and pause. All right, so when 2 irrational conjugates are multiplied, the result is always a rational number. It's pretty cool. So then we're going to simplify these by rationalizing the denominator. So if I'm looking at this one, I have to do the opposite. So square root of 2 minus 1, same on top and on bottom. So in this situation, in the numerator, I'm going to distribute 2 square root 2, distribute on here, minus 2. In this case, I'm going to go to the box, square root 2 plus 1, square root 2 minus 1. So this would be 2, negative 1, square root 2, positive 1, square root 2. Hopefully those cancel. And then negative 1. 2 minus 1 would be 1. So in this case, I just have 2 square root 2 minus 2. That is my answer for that one. Go ahead and take a moment to multiply these ones. Take a stab at it. There is a note here. It doesn't mean that we always want the denominator to be rationalized. In calculus, sometimes we want the numerator to be rationalized. You can go ahead and rationalize the numerator here if you wish. Definitely, you can skip that section, but there are situations in which you don't have to rationalize the denominator, but the numerator instead. So you guys are going to take a stab at this one, guys. Make sure that you filled in these boxes, though. Don't leave them blank. Okay, thanks, y'all. See you soon. Bye.